Sometimes the substances we use in chemistry are gases. And gases are particularly interesting because they don't weigh very much. And so if we wanted to find the number of particles in a certain amount of gas that we have obtained, weighing it might not be the best way. Using mass might not be the best way to do that. So gases have some unique properties, and these are things that you already kind of have some experience with. So let's start by thinking about these inflatable lawn ornaments that people like to put out in front of their houses at Christmas time. So here we have a jolly old Santa Claus, and he's inflated in front of the house. And, the night, it gets really cold during the night, and let's think about what happens overnight to that Santa Claus when it gets really cold. I'm sure you've all driven by a house where there's this deflated lawn ornament like the Santa Claus, and that happens when the temperature decreases. So when we have a very cold temperature, it turns out that the volume of gas decreases as the temperature decreases. So since the volume of gas filling our Santa Claus decreases when the temperature decreases, we end up with not enough gas to inflate the Santa Claus, and the Santa Claus deflates. So one of the things about gases is that they have this relationship between temperature and volume. There's also a relationship between the volume of gas and the pressure that we exert on that gas. So here we have a balloon, and what would happen if we increase the pressure on that balloon? So we could do that by squeezing the balloon. And when we increase the pressure by squeezing on the balloon, the volume decreases. So when we have a gas, there's these relationships between the different variables in the gas. And it turns out that we can express the relationship between all of the variables that affect the gas by writing the pressure times the volume is equal to the number of moles of gas molecules times a constant, which we'll call R, times T. This famous equation, the gas equation, is what we're going to use to determine the number of moles of gas if we know the pressure, the volume, and the temperature at which that gas exists. Let's see how we can use this equation to count the number of gas particles in a particular sample. So let's do this problem and see how this works. CO2 gas is at 25 degrees Celsius and 1 bar of pressure. How many moles of CO2 are in 100 milliliters of this sample? So the pertinent equation that we need to use is pressure times volume equals number of moles times the gas constant R times the temperature. Okay, so the first thing we need to know is that the gas constant is equal to 0.08314 with units of liters times bar divided by moles times Kelvin. So notice that we need to have the volume in liters, the pressure in bar, and the temperature in Kelvin to use this equation. So we have currently a temperature, but it's in degrees Celsius. We have a pressure, which is in bar, so that's good. We need it in bar. And we have a volume, but it's in milliliters instead of liters. So the first thing we need to do is convert the temperature to Kelvin and the volume to liters. The volume is pretty easy. 100 milliliters is the same as 0.1 liters. To get from Celsius to Kelvin, we just take the temperature in Celsius and add 273 to give us 298 Kelvin. Now, we want to solve this equation for the number of moles because we want our answer to be in terms of number of moles. So if we solve this equation algebraically for the number of moles, we can do that by dividing both sides by RT. So N is going to equal pressure times volume divided by R times T. And now we just need to plug the numbers that we have in our problem into this equation to get the number of moles. So we have 1 bar of pressure, we have 0.1 liters of the sample, R is 0.08314 liter bar per mole Kelvin, and our sample is at 298 Kelvin. So if I plug that into my calculator, I have 1 times 0.1 divided by 0.08314 divided by 298, and I get N is equal to 0.00404 moles of CO2 in the 100 milliliter sample that is at 25 degrees Celsius and 1 bar of pressure. Now it's your turn to figure out what volume of gas, which is at 1 bar and 30 Celsius, should you obtain if you want 0.05 moles of gas particles. If you do this problem correctly, you should end up with 1.26 liters of gas.